Hi, you're live with Tech Savvy Talks, and today our guest is Tushka Dermangieva. My name is Krasimir Kostadinov, CTO of Scalefocus. Tushka is leading our Java teams, and tonight we'll be talking about the present, past, and future of one of the most impactful technologies in the world today, namely Java. Tushka, can you present yourself?
Hi, Krasi. Thanks a lot for having me. I have around 12 years of experience, mostly as a Java engineer, before I started to manage the Java team. And I'm really happy and excited that today we will be discussing especially the topic of Java, because the language somehow defined me as a professional and defined my career.
Awesome. So let's start with some background maybe. How did Java start from a humble language to defining the web development nowadays? What was the journey? And you mentioned your journey, and what's the background of Java and how did it become so prominent?
Well, the first efforts about the language started at some microsystem where a small team wanted to create a language that will be used for smart devices, things like smart TVs, remote controls. With the emerging internet, they quickly changed their focus to create Java great for the web. At that time and now, one of the selling points of Java was its portability. You might have heard the term write once, run anywhere. Well, this was something huge. And the improvements on the language continued to emerge, creating different APIs and frameworks. Nowadays, we are familiar with JavaBeans, JDBC for database connection, frameworks like Spring Boot, pretty much anything you can think of that a developer might need for creating a web application. Not to be overlooked when it comes to Java, its multi-threading capabilities, which translate to better throughput and better responsiveness of the server, which means better user experience. Another thing is the security. Java has inbuilt security features, which for the web is really important, especially to protect some sensitive data. And at that point, Java was free to use, which was also something very important. Community also has credits popularizing the language. In summary, I think both the language capabilities as well as the good timing.
And what do you think were the reasons that led to Java becoming one of the, if not the most prominent language worldwide?
Well, there are different important stuff that made a lot of impact on that. One of them is the rich frameworks and APIs. Another thing is the community. And Java as a platform put the foundations, but the community and the frameworks is what drives Java forward. Something interesting I can mention is that you can find someone from the Java all over the globe. And for example, last year, Java user group here in Sofia, they invited a speaker from Estonia who presented interesting stuff about Kotlin, IntelliJ. Last year, during one of the biggest events in Istanbul, we made a connection with the Java user group there. And this year, we collaborate on different initiatives for knowledge sharing. And yeah, the events they organize, the conferences, events where you can meet people, discuss technology, I think this is the glue, basically.
Some of the technology people, as of late, I would say, have voiced some opinions that Java is becoming more and more complicated and thus has some issues with memory footprint, for example, or slow startup times. What does the community do, in your opinion, to address those?
Well, Java traditionally faced some problems related to the startup time and the memory footprint. In order to understand the issue, I would like to mention two things. One of them is the the so-called just-in-time compilation, which is very good for long-running applications, but it adds a lot to the memory. Another thing is the garbage collection, and usually it allows developers to work on their applications without the need for them to take care of the unused resources. But it works on the so-called cycles, and during these cycles the application can pause to some extent and add again to the memory and to the memory mostly. There are some language improvements. One of them is ahead of time compilation, as well as GraalVM, which is a specialized virtual machine allowing to build the application to native code. And the other thing is new generation garbage collectors, such as ZGC. Some improvements on the ecosystem. I can mention here some of the frameworks such as Micronaut and Quarkus. And yeah, there is a bad attention on the startup time and the footprint, but I think that the community is actively addressing those issues.
You mentioned, by the way, the frameworks, that the robust and evolved frameworks that Java has. You mentioned the community. We're talking, of course, about the language itself, of course. So what's the secret sauce of Java? I mean, obviously you have on one side the community, you have the frameworks, you have the language itself. Which contributed the most, if any, to the success of Java as a technology?
Yeah, as I discussed before, the community is something really important just because they try really hard to share all the experience they managed to gain throughout the years. And the framework as well. They go hand in hand, basically.
Okay. And speaking about the frameworks, by the way, there is a recent tendency of Java, the so-called frameworkization of Java, and some developers and engineers feel that Java, as time goes on, becomes more of a particular framework, especially Spring, and less driven by the development of the language itself, more driven than of the development of the framework than the language. Where do you stand on that? Do you think Java is becoming more framework-cased, or does it take away from the language, or does it enhance it? What's your take on that?
Well, in general, I think that frameworks are something really good, not only in Java, but in other languages. They basically provide pre-built components, tested as well, which leads to better code quality. And I think that they add a lot of benefits to the language. I remember when I started my first project a couple of years ago, and for me it was really difficult to understand the high level of the project and the application. If there was something more complex to be implemented without using Spring, it was really difficult. And then when I started on another project where Spring was used, it was really nice. I mean, in my opinion, if it wasn't for Spring, Java wouldn't be so popular in general.
And nowadays, Spring is far from the only framework in town. You mentioned Quarkus, you mentioned Micronaut, Helidon as well, Helidon. What do you think? Where do those alternatives to Spring stand? Is any of those supposed to be the next Spring, or Spring is so evolved that they will never catch up? Or what's your opinion on the competition amongst frameworks in Java nowadays?
Yeah, in recent years we see a lot of frameworks added to the list that can be used with Java. From experience, I can say that maybe Quarkus and Micronaut are the most used, especially when it comes to native cloud. Definitely the Spring is the most popular just because it's the oldest one. The documentation of Spring is great. There is a big community. There is anything you can want to do with Spring, basically. It's there. Critics often point to memory usage, but now we have Spring Native, and this problem is already solved. In general, I think that having more frameworks allows developers to choose depending on their project, and they have more flexibility.
Okay. And by the way, since I mentioned that in the beginning, Java tends to be the language in enterprise application development. Basically, it's like the golden standard. A lot of languages have tried to challenge that, and pretty much all have failed. What do you think contributed to the prominence in Java, especially in enterprise application environments?
Yeah, Java is all over the place, starting from healthcare, fintech, e-commerce, telco, anything you can think of can be written in Java. One of the main first selling points and importance, especially when it comes to enterprise system, is its portability. And it saves a lot of time for developers just because they don't need to build different versions of their application if they want to run it on different devices or for different operating systems. Another thing is the enhanced security. There are a lot coming with Java out of the box related to the security, and especially when a client data is managed, this is very important. The rich frameworks as well. You can do things like connecting to a database, cron jobs, messaging, networking, any use case you can think of. And the scalability and performance, again, really important topic. Java is, I would say, one of the most performant languages, and it has also some tools and frameworks so that people can build scalable applications. Last but not least is the large talent pool. There are millions of Java developers, and when it comes to real client project, we speak about business impact, and usually companies want to build their products fast, and it's definitely easier to find a Java developer compared to other languages.
Definitely. And by the way, I can attest to the performance of Java, since regardless, many people complain about performance in Java, but it's consistently ranked in the top 10 most performant technologies and languages. So as they say, there are two types of languages. One type that people complain about, and the others that nobody uses. So of course, when people use it, they will complain, but I definitely attest that it's a performant, and definitely the talent pool is there. I mentioned that many languages and new technologies came up throughout the years, and Java has definitely had its fair share of competitors throughout the years. How do you think it remained so relevant with the changing technology, with the changing IT landscape and so on, in the face of that competition?
There is something really important happened a couple of years ago, is the change in the release cadence. People who used Java before remember that we needed to wait a lot of years in order to start using the new Java versions with the new features in it. After Java 9, we have release every 6 months, which helps a lot. Another thing is the OpenJDK. And this allows companies and developers to use the free version of Java. And also, if they have something very complex to work on, they can create their version, and other developers, if they're okay, they can use it out of the box. Another thing is the so-called preview mode, allowing developers to beta test the new features. And in general, I think this openness allowed Java platform engineers and the community first to use the language and then to continue to innovate with the emerging technologies throughout the years.
And since Java has existed for, I believe next year will be 30 years since Java was actually introduced, how do you see a lot of technology has been built throughout the years in Java? Of course, some of the cutting edge technology right now is being built with Java. How do you think Java manages to both offer that cutting edge and also how well does it modernize when we're talking about legacy systems? How do we manage to support and modernize systems built with Java decades ago? How is that balance happening?
Well, there are a lot of frameworks and different patterns so that people can modernize their application. And there are different cases. For example, if the legacy application is already written in Java and the team of this company is knowledgeable, then the logical thing will be to use again Java. Another option would be, for example, if it's not written in Java, but again, if Java is something that will help them to modernize the application, is to mix and match with other languages depending on their use case.
Okay. And there has been a recent movement. I would say it started like 10 or 15 years ago. Some notable examples are Node.js or Golang, Rust, and so on. I call it a movement towards simplicity. Basically, technologies emerge that try to get back to basics, get back to the roots of programming and so on, without complicated frameworks, without everything is accessible, all the libraries are accessible and readable and so on. So where do you find Java in this simplicity movement? Is it going to follow it at some point, or is it going to weather it? Basically, not necessarily getting on the bandwagon, so to speak, but actually going its own way and persevering it.
Well, Java is not an easy language to learn, definitely. What I see is that there are a lot of improvements in terms of simplicity in the newest version. The thing is that especially for big enterprises, the change is really slow, I would say, and costly. And even there are more simple improvements, they don't use it basically. And Java as a language promotes readability and maintainability, so I believe even they introduce new stuff in the language so that it can be more simple. I would say that they will continue to somehow keep this readability.
Okay. Also, it seems throughout the years there has been a constant cycles of releasing technologies that are related to Java, but using Java as a platform, as a convergence of technologies, such as the bytecode, the JVM, and so on, but not necessarily being Java, like Clojure, like Groovy, like Kotlin of recent. There are multiple languages such as that. What do you think about the bytecode brotherhood, and where does Java stand in that growing family of different languages? Do those languages take away from the Java experience? Do they enhance it? What's your take on that?
Yeah, there are a lot of languages written on top of JVM. And in general, I think they are some kind of specialized for some purpose. I think that they bring some freshness, I would say, and flexibility to developers to use different languages. Most of these languages share some libraries, and I think that they somehow make Java innovate itself and in the ecosystem as well. Developers can mix and match depending on the case. For example, if there is a mobile Android application, then the go-to language is Kotlin, so they can mix backend with Java, and then for the mobile Kotlin. Another case I see a lot is using Scala for performance tests. In general, I think they are net positive to Java as a language.
And also Scala is the de facto language for basically Apache Airflow. It's actually written in Scala as well. So yeah, I do agree definitely that it enhances the experience, and a bit of healthy competition always helps, I believe.
True that.
And speaking about the fact that Java is so well established and so long-lasting technology nowadays, it was created before even cloud was a thing. How do you see Java in this modern cloud environment? Some languages even proclaim themselves as created for cloud, born in the cloud, whatever. Basically marketing terms. And is Java the cloud language, or is it struggling? How does it compete with the newer cloud born languages?
Well, when it comes to cloud, there are some key things that should be taken into consideration. One of them is the cost effectiveness. Most of the clouds, they work pay as you go. Another thing is the security. Just because you move your application there, you move your data there, and data management becomes even more important. And the scalability, again, just because if you don't make your application scalable enough, companies will pay a huge amount of money. I think that Java already has a lot of stuff in place in order to build cloud-native applications. Speaking of frameworks, we have Spring Native, we have Spring Cloud, and it has basically different functionalities such as service discovery, gateway, circuit breaker, retry mechanism, any use case you can think of about the cloud. Java also is integrated with the big giants, AWS, GCP, Azure. Speaking about serverless, there are AWS Lambda functions, we have GC functions, Azure functions, and Java is among the small group of languages which can be used with these frameworks I mentioned. And looking ahead, I think the improvements will continue to happen, and the innovation as well. Just because hybrid cloud is a hot topic, machine learning and AI as well. But I believe that most of the stuff are there already.
Yeah, I definitely agree that there are like a handful of languages that are at the core of each and every cloud, and you can build pretty much anything in the cloud with, and Java is one of them always, regardless of the cloud provider. So definitely it has a great future in the cloud, and also it is one of the fundamental technologies in the cloud nowadays. Since you mentioned the future and how things will develop, what are the current developments and trends that you see in Java development and the technology stack and the tool chain and so on of recent and currently upcoming that you think will make the biggest impact on the Java ecosystem?
Well, definitely it will be something related with machine learning and AI in terms of improvements, I would say. But there are a lot of projects with very interesting names, by the way, such as Project Loom, related to improving the multi-threading capabilities, Project Valhalla, that aims simplicity, Project Panama, which allows Java to work with other languages and being interoperable with them. And I believe that this will be the way to go. Basically, the focus will be on improving these projects and promote them more, just because even they are there, I don't think developers use these new features. And the reason is because the innovation is very slow in some of the projects.
And you already mentioned it, speaking about the future, of course. It seems nowadays, by the way, I had a personal experience on that. It seems that Java somehow became stranded on the sideline of machine learning, so to speak, because everyone's associating basically everything that happens around data for machine learning itself, whatever. It equates Python in people's heads. And I had a personal experience of a friend of mine that was asking which programming language should I learn? Is there any sense in learning anything but Python in 2024? So what's the role in Java in this machine learning niche that is rapidly growing? Do you think it will establish itself there? And what will be the future in Java and ML?
Well, in my opinion, the language is only a tool to create solutions for some problems. Definitely, the Python is the go-to language when it comes to machine learning and AI. When we speak about these two topics, the most important thing is the data. How we access data, how we collect data, how we process data, how we extract data, make decisions based on that data. And I think that Java has very strong position here, just because there are already frameworks either written with Java or built for the JVM, such as Apache Hadoop, Apache Spark, Apache Kafka, Elasticsearch, to mention some of the different frameworks and libraries for AI, such as OpenNLP for neural language processing, things like deep learning for J, which competes very well with LangChain. There are with TensorFlow actually. There are Spring AI, of course, and a lot of different frameworks. I don't remember the names, but how to process images, visualize things, etc. And when we speak about innovation, what is usually happening is that there are early innovators, early adopters, and then at some point we start to think about, well, how we will introduce these changes into enterprises, and people start to think about they start to think about how they will implement things, how they will integrate with their existing systems, how they will maintain them, return of his investment, just because everything costs money. And as we discussed before, enterprise speaks Java. And in my opinion, the logical thing, if you are already familiar with the Java and its ecosystem, having all these frameworks already in place, if people and companies want to experiment with something related to ML, to start to do that with Java and try it out. Of course, if they don't have experience, then go with Python, especially for data analysts. For them, it may be easier to learn Python. It definitely will be easier to learn Python compared to Java. But I think that Java has place, especially in the machine learning and AI ecosystem.
And by the way, to put things in from my perspective, there have been numerous trends in the past 15 or 20 years, like cloud computing, big data, blockchain, and now AI, ML, and so on. Java has consistently provided excellent ways to actually leverage those technologies always. All the impactful technologies in those fields you mentioned, Hadoop, LangChain, or TensorFlow, or whatever, they can also always be used by Java. So you're not cut off from the cutting edge of technology, and you can always leverage that. And by the way, since you made the parallel between Java and Python, which is a natural thing to do, both are quite popular, but one thing that's not on the focus nowadays, but I believe in the upcoming decades will become focus, especially with climate change and so on and so forth. The notion of green coding or green software engineering. Nowadays, there are already plugins for static code analysis systems, how green is your code, and so on and so forth. And the parallel there is Python is probably one of the least green technologies we can use. We are, as a community, we are moving to using ever less green technologies. Like blockchain is quite not green, Python is quite not green, and we're using extensively Python nowadays. So what do you think will be the role of Java in green code and green software engineering in the near future?
The topic you are raising is really interesting. Something recently I heard on the news is that the only thing AI cannot generate is power and electricity. And agencies are predicting that there will be an energy crisis, and the consumption will increase 10 times by 2026, which is huge. Smart coding alone will help. I mean, developers can use good algorithms for their applications. They will try different approaches to optimize their code, not only in Java, but in other languages. But I'm expecting some interesting discussions between different governments, just because the technology alone, I don't think will solve this issue. It will be part of the solution, but not the only thing.
To add to that, a few years back, now it comes to mind that there was a survey in which blockchain usage was ranked among countries in order. It was among the top usages of electricity, even compared to countries. It was in the top countries if you only rank the usage of electrical power for blockchain. So it's huge, but it goes unnoticed a lot of the times. And going back to the question of my friend, is there any sense in learning Java versus Python and so on? What do you think are the career opportunities currently for Java in the job market? Because everyone's talking about Python, I'm not sure that is as big of a job market as Java, maybe, but what's your take on that?
I truly believe that learning Java, as someone who is entering the IT industry, will be beneficial. Just because Java is quite complex language, as we discussed, and it learns developer more about how to think and become real software engineers rather than learn how to code in general. I'm joking with my team that no matter what happens with Java, we will be able really fast to learn another language, basically anything, just because we managed to basically learn Java and everything around Java, all the frameworks. The learning curve is big, and I believe they will benefit definitely in terms of job openings. I did some research, and basically Java is among the top 5 languages for job openings. I mean, the first one is at the moment Python. It wasn't a couple of years ago, but because of AI and ML. And the openings about Java, even during COVID, even during some layoffs and after layoffs, the openings are basically, I would say, the same. There is some raise in the openings for Python.
So you basically see the trends for Java openings and the longevity of the technology.
Definitely the pipeline will be steady. Not sure if it will increase, but there will be job for Java developers for the years to come.
And the more interesting part is by using Java, you can have an impact on any industry and any particular business case and so on. It is not a language and a technology that's focused on one thing or a handful of things. It's truly something that is used in production at scale for pretty much everything you can think of.
Yeah.
From IoT to enterprise to machine learning to you name it, fighter
Any
jets.
domain you can think
You can
of.
program drones with Java. It doesn't matter. So definitely it's a technology to know, and it's a technology with, if not the biggest, arguably having the biggest impact on the tech world. With that, since we're close to our wrap-up time, as per tradition, we'll give the audience the chance to ask a question. I believe we might have some questions already. So let's go to questions from the audience. Still waiting on some questions from the chat. While we're waiting, there have been a lot of developments, pretty much like Java has a lot of competitors in the language space built on top of the JVM and so on. The JVM itself has a lot of competition that was built throughout the years. Even on Android phones, for example, we had like a few virtual machines running Java throughout the years. We have open JVM, we have a couple of proprietary JVMs, like one from Microsoft. Basically, everyone is trying to build their own JVM. What is your take on this constant popping up of new execution environments for Java, and is it beneficial to the technology space, the Java ecosystem more specifically, or does it take away from it?
I think it's in a way beneficial just because definitely it brings innovation. I mean, if the companies you mentioned face an issue that is not yet found in Java and Java can benefit from the solution, I think it's definitely beneficial. As the languages which are built on top of the JVM, they bring innovation, in my opinion.
And everyone must be compliant to Java and its workings. So let me read the first question from the chat. What security considerations should Java developers be aware of when developing AI and ML applications?
Well, definitely data access is something really important, just because I think it's already an issue. I don't know how many companies allow their developers to use things like Copilot just because they don't know where their data will go, as well as people who are using ChatGPT and other stuff. So definitely something related to the data access will be the most important thing.
I can add that there are a few trends nowadays. One is basically enabling row-level security on data, where the data is kept. It's not directly related to Java, but the idea is, regardless what system, it might be Java, it might be some queuing mechanism, it might be some integration bus, whatever. The security of the data is implemented where the data is. For example, the data lake where the data sits and so on. And that enables, regardless of the system that uses the data itself holds the metadata of who has control over it, what they can do with it, how it can be accessed, and so on and so forth, which basically centralizes, regardless what systems use the data, or machine learning models might use the data, whatever. Control over data is being centralized and kept as close to the data as possible. And the other trend that I'm seeing, the so-called data mesh, is the concept of data being exported as a product. Basically, you have some data as a business line or as a part of a company or as a company, and you want to expose and monetize, or even not monetize, but bring value to the company or to the clients or whatever, you're basically exposing that data thinking of data as a product being exposed and bringing value to other systems and so on, which again brings its own challenges. But the best thing, as I said, Java is one of the pioneers of most new developments, and all the new tech that comes with, regardless what you're creating, if you're creating a data mesh or so on, you can do it with Java. And the other aspect, since we're speaking about ML AI, ML and AI have pretty different way of working, and actually pretty different life cycle from the general codes that we're using. And that's why we need things like MLOps. But the challenge here is the security field in ML and AI is not as researched as with common code. And that's why we are still finding out ways to attack different models. Most, of course, popular attacks are on large language models and small language models, but we have various types of attacks that we're literally every month I learn of 2 new types of attacks over especially large language models, jailbreaking or various other types of attacks. So the short version is Java will soon get some tools together, probably in the form of some libraries that are available for other languages as well, to secure models against security threats. But those threats change almost daily. So that's a thing that you must be aware of, and it's not the technology so much as the vulnerabilities of AI in general that are important.
Yeah, and regardless if it's AI or not, something developers can do is related to doing some static code application analysis. There are a lot of tools that they can use, such as SonarQube. Another thing which is also really important is the so-called dynamic code application analysis. Tools like checkmarks and Veracode, they identify security issues, and they are especially used in the fintech sector, where the security is one of the most important things. So don't think about security or some other general software engineering stuff specifically for AI and ML always. I mean, if you do the things as a software engineers, even if the industry is different, if you keep to those approaches, I think you will be able to build secure code.
To give an example, regardless if you are using an ML model or you're using a classical REST API, for example, if you are not trusting user input, never, you're more secure regardless if that input is for a machine learning model or for REST API, then if you just take it and treat it as secure. So yeah, basically follow the best practices. In most cases, they will help you out regardless what you do, and there are some specifics in ML that you should always be aware of. We have quite a few questions actually. So the next one is, how can Java be used to implement real-time ML predictions in large-scale production environments? So it can be used in a variety of ways. When we're talking about, and you can add if you want to that, sorry,
Yeah,
I
go
started anyway. AI, and especially the current models that we use, usually use lots of data to be trained, fine-tuned, and so on. And even more data when they operate, because they are constantly acting upon data and needing data to even improve themselves and work. Java can be used, Java is used, I mentioned Apache Airflow, for example. Java is one of the underlying technologies, together with Python, of course, to bring data to an ML model or a system that uses ML and so on. So you need lots of data, you need the data to be structured in a specific way, so it's useful to the model, features for the model basically to be selected. They need the appropriate data quality and so on. All that, so Scala, Java, and other technologies, getting the data to the ML is one part that Java really makes an impact. Of course, using message bus systems that Java is quite capable of, microservices and so on.
Yeah, different architecture as well, and I already mentioned some frameworks written in Java, such as Apache Spark, Apache Hadoop, which are used a lot for big data.
And with regards to predictions or forecasting and or regression models and so on, Java can be the glue that ties everything, the data, the execution of the model, the automation of testing of the model. Not a lot of people are talking about, yeah, we implemented some machine learning models in our systems, but how do we maintain and test them and make sure that they're not degrading? So yeah, Java is pretty important, not so much for the prediction side, but definitely on keeping everything together. What is the role of Java in the development of AI-driven mobile applications? What is the specific advantages or limitations in this context?
Well, we already discussed the portability, and this is key here, just because everything that developers can build for any device can be executed on mobile as well. In terms of limitations, to be honest, I cannot think of anything at the moment, and haven't tried it yet, especially for mobile. And I don't know if there are some special libraries that can be used in this regard. Krasi, I don't know if you have
pretty
heard
much
of something.
You can, of course, Android development is a great example. You can write Android applications still in Java, and they work perfectly fine. You can use the same.
Kotlin.
But
I mean,
in terms of how AI can create applications, I have used for mobile development personally only Copilot with Kotlin. I believe it doesn't make any difference if it's Java. So you still can use AI. Some of the mobile applications, what I'm seeing, they become intelligent applications. Basically, they have AI models that run on the mobile device and do some cool stuff and provide some features that are so far not seen. So basically, Java can be used regardless if you want to fine-tune the model or to execute the model. So it's still prevalent in the mobile space, not as much as it used to be, but definitely you can leverage pretty much whatever you want with Java. One question from this one is not anonymous. It's from Cvetomir Cvetanov. What would you say are the most important skills for Java developers in the near future?
I think that Java developers should start getting familiar with all those frameworks which are already in place. By the way, there are a lot of information online, books, tutorials. You can find a lot of information there and start experimenting. Definitely, I would say get yourself familiar with these frameworks. There is nothing different than what you're used to use in your application. Of course, there is more learning curve related to NLP in general. There are a lot of different architectures. I mean, microservices, monolith, service bus, etc. Yeah. These are familiar to the Java developer. Definitely, when it comes to the emerging ML and AI, there are interesting architectures, and people should get familiar with them so that they stay competitive.
Okay, just want to add that in my opinion, the most important things that a future or a current Java developer should know, besides the technology itself, which of course you cannot, if you don't know the tool that you're using, you cannot be a master at anything. But the important thing is, and the thing that's lacking, in my opinion, in today's software engineering community is try to learn the basics well. If you understand, so if you are using Java, which is an object-oriented language, know object-oriented programming well, know its shortcomings, know its workarounds like solid principles or whatever. If you are using persistence, regardless if it's JPA, regardless if it's Spring Data, regardless whatever, try to learn the fundamentals as well, which is object relational mapping. And you will understand instantly all the ORM frameworks because they are implementing the same concept. So if you know the fundamentals, it will be easy to learn the specifics of the framework and the language afterwards, because Java is implementing the object-oriented way of thinking towards programming. So if you know OOP well, you will understand Java fast.
Exactly. I do believe that basics and core knowledge is really important. We do quite a lot of interviews, and I see a lot of people, they use frameworks, for example, Spring, but they don't know solid principles, they don't know some basic object-oriented principles. And yeah, they can implement features, but if they want to progress and work on more interesting stuff, I don't think they will be able to do so, and companies will allow them to do so if they don't know the core.
Yeah, absolutely. And since we're almost out of time, I want to thank you for the participation tonight. I want to thank our guest, Tushka, for sharing wisdom and knowledge she has acquired throughout her career with Java, because all your career has been working with Java, right?
Not only, I mean, I was working on one project with Golang a couple of years ago, and can confirm it was really easy for me to switch to Go. I mean, it took a couple of months maybe to learn the syntax, etc. But Java is my main specialty throughout the years. I really like the language. And to the question, what is the future of Java? It's alive. It won't go anywhere. It has future. So people who are thinking to join the IT field, definitely Java is something really nice.
I can go even a step further as final remark, and we'll close today's session. Java is not only having a bright future, Java will be one of the driving forces of the, at least the near future. Part of my job in the company is to follow trends, and definitely Java is one of the major players that will shape the future of technology, at least in the upcoming decade. So don't be hasty, don't bother yourselves with the future of this and that. Java is a great place to start and build a career out of. So
True that.
Thanks again for participation, and hopefully today's session was enlightening and interesting to you as it was to us. So thanks again, and see you next time.
Thanks for having me, Krasi.
Thank you.